Alright, I'm back again and gonna go through some of the updates I've made to this app. Added a lot of features. Um, I also made a world where I started them off with the ability to attack. So I made 4 different configurations for these machines where, in addition to like rotating around 360 degrees, and then if they see any food, then walk toward it and eat it. I also have an extension onto that where if they see another machine, they'll move toward that and attack. And then once whoever survives that, uh, will be able to eat the food from the machine that died. So yeah, I did make these 3 machines, and then I started them off. So before I go into that, I'll show some of the features I added. All right. There's a lot of right-click options. So this one, like copy machine, will let me, if I click on a machine, I'll be able to copy it and place a copy of it somewhere else on the board. Same configuration. And let's see what else we got. I have the ability to override the specify output option. I have the ability to override what the machine would normally do on a specific turn and just specify what I want it to do. So it lets me take control of the machine for 1 unit at a time. And I'll also show this other feature here where, like, let's say I'm adding a global memory object. Specify output. So I have it show all the different options. So I could demonstrate like the push operation. If I send G, that tells the app that the next move that this machine is going to take is G. So I'll advance time by 1 unit. G. I did the pull operation, so that's why everything moved down. And if I want to do the push operation, then U, and it moved up 1. Now it shouldn't let you push if there's something else in front of it, so I can test that. I'll add another global memory. It shouldn't. I did code it so that if there's something else, there's not an empty space in front, it won't let you push. Didn't actually test that, but we'll just test it now. So push, advance 1. Yep, so it did not let me push. Now if I try again, pull, I'm going to pull it this time. Next time, that worked. And then I'll try to push again. So that all works. So what the purpose of the global memory is, it would give them the ability to store some value that they can reference. They give it a unique identifier of some letters. I think just the lowercase letters are the only ones that I allow. And then also you can save some value, and that's also some kind of lowercase values. And so that allows them they're standing right in front of one of these green squares. They can save some memory, or they can recall some memory. And they're all the memories are all linked together. So one purpose I could see them making use of this is if you had several of these spread across the map. Anything that is saved here can also be retrieved here. So there's potential for instant communication across the map. And they could reposition them with the push and pull operations. It's asking a lot for them to be able to figure this out on their own, but it should be possible for them to stumble onto the usefulness of this. And so I can show what it would do if it did save. See, when I click on one of these, it says total memory item saved. So I'll specify output, and I'm going to say store. And then this is where you would actually I'll do A, just A by itself, and then something that's not one of those lowercase letters. So I'll do like K, and then A B B B C C C A A. Okay, so just the letter A. If I ever do a load operation, global recall it's called, and I say just global recall A, it should return this data after I do this. First, I will send this command. I'll advance time. And it says it's number of items saved 1. Now, I will do the recall operation. And I think you could just end it with A, and it should be able to work with that. Otherwise, I don't know if you need to have a K or something that's not a lowercase letter. I don't think you need it, so I'll try that once. Advance time 1. So it sent this command out, JA. So you're asking for it to give you the data that was stored at JA. I'm advancing time again, one more. Yep, here it is, A B B B C C A. So it's giving you back what you put there. I think you should be able to override that. If I were to save something else with the same name, it should override it. I could try that. I haven't tested it to this detail, so I'm surprised if there's a bug, but I don't think there will be. So global store, global store A. There we go. Bunch of A's. Okay, it's still saved. Still only one saved, so that's good. And then I'll do the recall operation. Advance time again. That's sending this telling it I want to retrieve whatever is associated with the letter A. Yep, it did override it. That's good. And I'll add one more. I'll just add one more. B. 4 B's. And you get 4 C's back. And this option to specify your own output, this was pretty helpful for finding all the bugs with all of these unused options that haven't been played around with yet. So, okay, so now you see that there's 2 items. I don't actually have a cap on how many items can be saved, so I mean, if they ever really did figure this out, there's a possibility of running out of memory, maybe. But and then there's also each of these machines has their own long-term memory. It works very similar, where they can accept that it's only for them, just a way to store data if they wanted to be able to. If they ever figured out how to do that, they would have a ability to store and recall memory that way. I could do AB, and then that's going to return a bunch of C's, like this, or about a bunch of C's, then a bunch of D's. That's just AB. Advanced time. Yep, bunch of A's. And then C. So if I ask for AB, it should give me a bunch of C's and a bunch of D's. That's time. That's one more. Yep, a bunch of C's and a bunch of D's. So, like, if it were to ever make use of this option, what it would do is it would have to have it would have to put something on the left side of like the tape so that it knows, okay, I'm calling the memory, and then whatever it gives me on the next unit of time for whatever I get back, react to that memory. Um, and then put a couple more machines on this map here. So another option was an option to decode the machine. So what that'll do is if you're ever right in front of another machine, you could send this D command, and what that'll do is it'll put all this code here as the input for the machine in front of you. So I will advance time 1, and you can see it sent the D command, and I'll advance time 1 more. And now you got this this code. So the usefulness of this option could be it could help them to be able to identify each other, but you have to be right in front of them for it to do anything. But it could get useful if they ever pick up on picking out a few pieces, of, like a snippet of code here, being used to identify what kind of machine it is, whether it's harmful um, or just something like that. But it could also be useful if to at least give them access to be able to understand their own code. Maybe that's that's asking a lot, but I'm giving them the capability to figure that out, at least with the option. So this is the place encoded machine. First, I'll show this option here. You can, I got an option where you can do copy machine to clipboard. So what that does is all this code here, when you select that option, when you right click on a machine, you can copy that code into the clipboard. So if you ever like want to share, or store a machine, off the app here to be used later, you can do that this way. And if you ever want to place it on the map, again, place another copy on the map, or make a modification to it. Maybe you can go to place encoded machine, and then now prompt for the code for that machine. I don't have a lot of verification on this option, so if you put in any kind of machine that isn't really has a lot of like invalid rules in it, I mean, I do enforce rules on these machines, but only as mutations happen. So if you got like some states that don't have anything connected to it, I think it'll allow it, and I don't put any validation checks. Or if you have if you have an input, um, like if you have a state where you have it go off in two different directions instead of one single direction for any one like type of input, like if it sees the letter A on the tape when it's reading, if you're giving it two different ways to go, I think it'll go to the first one it sees. But yeah, you just have to make sure that it's proper. I mean, otherwise it could be a little screwy in the app when you're running it. And then you got the option to add all these objects like the stone. You got these different weights. So let me put a weight of 3 on this one. So I added a stone to this to the map. Now what the weight of 3 means that it means that you got to push on the stone 3 times in order to move it. So I can show that. Or pull. Push 1, advance time, nothing yet, and then push again, advance time, still nothing, and push again, advance time. Now it moves. So you could also add food. Now I got some other options that would make setting up a map a lot easier, like adding 50 random ones across the map, or 50 food across the map, or 50 global memory. So if I do stone, I also randomize the weights. This one's 6, 3. So this is just like stones. There'll be obstacles that these machines will just learn how to either use or navigate around. And if they were to develop the skill to push and pull, they could maybe use this to build like a shelter for themselves, or like a barrier. And you got the ability to delete objects. So I delete that one. All right. And we'll advance. I'll add a bunch of food here so they reproduce quickly. 50. Add another 50. Add another 50. So they should be able to find food pretty quick. And then this auto advance will basically execute 100 steps every second. Okay. I also I have the setting option where you can control a lot of the variables in the program. Like the way I have it, where they can only see 5 squares ahead. You could change that here. You could put in a value. Put in 7. Now they can see 7 ahead. Or setting a max population. Right now it's 1,000. Well, let's say I made it 3,000. I tried this once. It got really cluttered, but I can try that. Let it run. Gets pretty cluttered, so I kept it at 1,000. I could make it 5,000. the max amount of food allowed to be shown on the map. When you attack, how much damage does it cause? Whenever they execute an eat operation, the maximum number of steps that a Turing machine, one of these units, could execute when in its decision logic. Like you can change that. How much energy they start with when they spawn a new one, when a new one gets spawned. The percent chance of a mutation for every offspring. And when a food appears, how much amount should that food be? And another one I just thought of is like I have it default when they eat something, it'll spawn 20 copies of themselves. I could put a variable in for that too, so you can manipulate how many offspring they have after each step. But this allows me some variation and some variation in the initial conditions of it. And most importantly, I got a save option now. So you can save your work, you can save the state of the map, and you don't have to worry about starting over, and you can resume exactly where you were before. So I can take a screenshot of this. Take a screenshot just to show that if you save it and then load it again, it'll look exactly the same. Alright, now I'm going to close the app. Now I'll load the file I just closed. Curious on the size of this. I'm going to check the size of it just to see how big these are. 7 megabyte. Alright, load it. And there you go. Bring up our screenshot here. So everything got saved, even all the the statistical information. Tested this a lot to make sure it would, and even the all these settings we had here, those got saved as well. And then you could resume it again. They're all kind of frozen now. All right. And I did fix a bunch of bugs that I found. So it's more stable. I could go back now to the world I had started earlier. So this one I had those 4 different machines. So they eat, and then if they see another machine, they'll walk toward it and attack it. And there's 4 different variations. One they'll move forward when they're searching for food or another unit or another machine. This one will move up. This one will move right, and this one will move down. So those are the differences. And then you can run it, and I'll run it at 10 here. I put 2 units of food ahead of each of them, so they would instantly multiply all over the screen. So get a nice distribution going in the beginning, and you can watch them slow it down, watch them just fight. And that's what I was hoping for in the beginning, that there would just be a lot of fighting back and forth, and all of them would be trying to outdo the other. One time when I ran this, though, after a time, what ended up happening overnight was, I think all but 3 of them went extinct, and then all of them would be moving upward together. So it's like they were trying to avoid having to attack each other, and they were all moving consistently equal distance from each other. Um, kind of like harmoniously, kind of like what I was trying to avoid in the last one. Last map, they were always working together, and this one it seemed like they were kind of working together again, except what they were really doing is one was trying to chase the other, but then the one ahead of it would always be moving upward. So, they would be kind of like running away. One's running away, and another one, well, the one running away doesn't actually know one's behind it, but yeah. I tried to start them off as like a competitive nature, but it's like they're developing a cooperative behavior. Yeah, even though I tried to start it out so they wouldn't do that. So I did what you saw there. I did have it. I did let it advance like an hour or something, maybe a couple hours. So we can see what that looks like later on. After 100, about 127,000 units time later. So we're at a point now where it's been 33 mutations since the original. I'm going to probably move this label so it's down here, so it's not in the way of this code here. We can see the code of the machine that you clicked on. I saw this one, this one just likes to go back and forth. Yeah, it likes to go up. Yeah, it's like it does a circular pattern. And you can see how many times they've executed all the commands now. It's not a byte array anymore, so you can actually get real counts. Like you could see when it tried to transmit data. That's another thing I didn't show. You can transmit a message to nearby. Like if one machine's within 5, you could send T and then some letters, and then the machine that is in front of you, I think it has to be directly in your sight in order for them to receive it. Unless I did code it where it would be 5 in any direction, but I'm pretty sure it's just um, in front of you. It only transmits if it's in front of you, and then they'll receive it on their input, the transmission. There's a lot of attacking. They're still they are still attacking, and you can see that they do execute these other commands, but it's just randomly. So in order for them to actually use these commands, or to develop a use for them is they'd have to stumble on, like, randomly. There'd have to be a mutation that would the ability to pull an object. They'd have to happen to be right. They'd have to happen to get a mutation that causes them to execute the pull command when they're right next to an object, or something like that, where it could stumble onto an ability to pull, and if that could improve their chances of finding food, then it would stick around. But what we see here is about 19,512 times where they've executed the pull command. Most likely, it probably was an invalid operation. They weren't next to anything, but they might have randomly pushed one of the objects at one point. I don't keep any stats about that. If I kept stats on successful pulls or pushes or transmissions, um, yeah, but this would give them the ability to communicate with each other, just transmit data. Yeah, so now that the code, I put this on GitHub so I can upload these code changes shortly, and then yeah, now that it's at this stage, now we're able to run create worlds and run them long term and save and resume, and we could really see like what happens when you run one of these worlds for several, like weeks, or just to see what would come of it. All right.